All right, so we're live. I'm going to be chatting about React events in depth today, and I'm joined by Dan Abramov and Ben Alpert. Hello.
Hey,
So yeah, I guess just you can see in the description of the YouTube video, this was inspired by a pull request that Christopher made about the events or that had to do with the event system in React. Really actually cutting down a lot on the size of React itself by like a kilobyte post gzip, which is kind of significant. And just kind of a conversation about the complexity of the eventing system in React in general. And so Dan suggested that we have this chat to make it a little bit easier for people to contribute.
yeah,
So,
so
yeah.
actually disclaimer, I'm on the React team and I actually have no idea how the event system works. So this will be my introduction.
Awesome, cool. So let's hear it, Ben. Tell us all the good
Yeah.
news about
Um,
eventing.
so the way React works is we implement the event system completely by hand and try to not rely on the browser to the extent that that's possible, because that allows us a little more flexibility in exactly how we process the events, how they bubble, and it also provides a little bit more cross-browser consistency, which was especially important in the days of IE8. Not quite as important today, but still valuable because some things like the on-change event we do completely custom, and then we have a few other events which I think aren't completely supported widely, like the mouse enter, mouse leave events. I think are not quite supported in every browser. Um, so I guess I can just walk you guys through the code, at
Yeah,
least at a high level. So why don't I share my screen here? And you can probably see yourself now. um, so here I have. Why don't we start here in the whoops uh, in this file called event constants. Um, so this file declares our top level types, and basically a top level type is a browser event that we listen for, and so these are not necessarily the same as as the events that you listen to in your component, but this is just basically an enum that lists all of the different possible types of events that we might listen to. And so, for example, we listen to the blur event that the browser gives us, and that's represented by top blur. And then what happens is we basically have a mapping of what to do with each top level type if we receive an event for it. So let's say that you did add an on blur handler to one of your React components. Then when we process that, we're going to so we have a number of event plugins in the system, and from the name plugin, you might think that you can bring your own plugin and add it to React, and that's not actually really something that we support. But we have the event system is split up into a few different event plugins, which are used for different types of events. And so for most events, we actually just listen to it from the browser and basically pass the event through without really changing the bubbling semantics too much. So if we get a blur event from the browser, then we fire the on blur listeners in your components. And so for all of those events which have the straightforward translation, those are handled by this simple event plugin here, which I have open now. And so you'll see that actually at the top of every event plugin file, we'll have these event types, and then later on, when we export the event plugin, we export these event types, and those are what the event system uses in order to determine which plugin handles each event. And so blur should be in this file. If I scroll up, so that this is again in the event types object, you can see we have this blur event. This first key that just says blur is actually only used internally within simple event plugin, I believe. But these other names here show what name you use in order to add that event listener. And so you can see that the on blur name is right here in this line where it says bubbled. And then we also actually support a capturing event for most of our event types, which is something that most people don't know and doesn't actually come up that much. But the way bubbling works is it first goes through what's called the capturing phase, where it bubbles from the top to the bottom, so like from the window to your inner component, and then it bubbles back up to the top. And so most people only add event listeners in the second phase for most apps, and so that's where the normal event bubbling that you're used to comes in, where it starts at the actual component that got a click or got a key event or was blurred, and bubbles up to the top of the browser. And so here, the simple event plugin is saying, I want to handle both the on-blur event and the on-blur capture event.
I have a question.
Yes.
Can you give an example of where I would want to use a capture event in an app? Like, what is the use case for capturing?
Yeah, so it's actually very, very rare that you want to do this, but you can imagine potentially something like if you have some dialog box and it has some components inside it, and for some reason you want to intercept every click to that dialog box, and you don't want to let one of those inner components handle the click, then you might use this. And like I said, this doesn't actually come up that much, and I'm not sure I've ever used it in one of my apps, and you know, you don't run into it that much, and so maybe we should even look at getting rid of it from React, because it's just additional complexity that is very rarely needed. But for now, we do actually support that, and so talking about it will probably be useful as we're walking through this code. And so in the event types map here, we have this blur name, and then also if we scroll down a little bit, let's see, top level events to dispatch config. What is this for? Okay, so in addition to, so these registration names is what we call the actual property that you'll use in when adding an event listener, and then the phased here refers to just the bubbling and capturing phases, and almost all events that we have do use this phased registration names. And so below, I'm just gonna write it out here. We have what we want is when you add an on-blur listener to your component, we want to add a top-level blur event listener to the window in the DOM. And so React needs to know that when you have an on-blur, it needs to add the top-level event listener. And so we do that with something called dependencies in this event type config. And in this case, you would just want event constants dot top blur, or top level types, I guess, types dot top blur, which just says whenever we add an on blur or on blur capture listener, we need to make sure that we are listening to the top blur event in the DOM. And so you can see I just added it inline here. We actually have some tricky metaprogramming here that just loops over all the types and fills it in. So we can see that for the blur event type, we need the top blur event. so that this is just a tricky way to fill in that map, but effectively you can just imagine that we had hard coded these dependencies on each of these event types.
Okay, and just for clarity, the pull request that Christopher has out is doing like some additional metaprogramming type stuff to reduce the payload size of React. Is that right?
So you can see that in the pull request he has, here's the blur event config that we were just looking at on the left side, and what he's done is just made it so since all of these follow the same pattern. Just making it so it takes the name blur and then it sets that to have phase registration names, and then an on, and then it capitalizes the word blur and appends it, and then on blur capture is all that this is doing. Yeah, so just doing a little more at runtime instead of hard coding it all. And so the React event system will then look up the dependencies for the event type, and now needs to actually do something. So it knows I need to add the top blur listener, and the code for that is actually in, I believe, this file called, React browser event emitter. And so what this does is it handles listening to the top level event types. And so you can tell it, I want to listen to the top blur event, and then it will actually go and call add event listener on the window object in the browser.
Hey, Ben, could
yes.
you actually make your font size a little bit bigger and
yes, absolutely.
Make the width of your window bigger?
How's that?
Yeah, that's great.
Okay, cool. Yeah, sorry about that. And so we have this function called listen to, I guess. And so listen to would receive arguments. So this would be like .listen to, and I guess registration name would actually be on blur in this case, and then it'll get a reference to the document, which is almost always the same as the global, although if you're rendering into an iframe or another window, then it might be different. So we do pass this in. And so what this does is it looks up the dependencies basically in the same map that we were just looking at, and so then dependencies will be so that this will just be top blur basically, and then we loop through the dependencies, and we have slightly different configuration for each of these events, because in some cases, like here, we just look at this first example, when we need to listen to the top wheel event, depending on the browser, we might need to listen to the wheel event or the mouse wheel event or the DOM mouse scroll event. But these actually all basically have the same behavior, and so that's why we treat them the same outside of this file. And so
I'm so glad that React does this for me.
Yeah, so when you write on wheel, then React goes behind the scenes and says, oh, I need to listen to wheel or mouse wheel or DOM mouse scroll, and it sort of normalizes those for you. And similarly, scroll has slightly different modes depending on whether your browser supports capturing or bubbling the scroll event. And so that just determines when React gets to listen to the event. We actually always simulate the capturing and bubbling phase after React has received the events. And so in this case, I guess, blur would end up here and would listen to either the focus and blur events in some browsers or the focus in and focus out events in IE. And those, I think, are effectively actually the same as focus and blur are in other browsers. And so if we were in IE, then we would listen to the focus out event. And whenever we receive a focus out event, then we're going to say, oh, we received a top blur event. And so we have special logic for wheel, scroll, and focus and blur, I guess. And then for every other event, we just look up the event name in this mapping at the top of this file.
Okay, so this is just to make sure that I'm understanding correctly. So this is like event delegation to the max, because you're delegating all events to the document. You pass in that document to that function, the listen to function,
Yes.
and except for a couple of those special cases, you're basically just listening to that event on the document.
Yes.
Okay. Cool.
Yeah. Yeah. We also track which listeners we have, so we only add the listener once.
Oh, okay. Yeah. Very cool.
Per document. And so if we actually look at, I'm actually not sure if this will be instructive, but hopefully this is instructive. If we actually look at what these calls do to trap bubbled event and trap captured event, then these are going to be, I think, in React Event Listener. And so what this does is, so once again, this takes the top level type like on blur, and then the event name, which is either going to be blur or focus out, depending on the browser. And then this is going to be a reference to the document, this handle. I don't know why it's called handle. Could have called it node or document. That would have been clearer. But we just call event listener.listen, which is a little wrapper around add event listener and attach event. And then we say when this event fires, we want to go call into React Event Listener .dispatch event and pass in the top level type. And so that means that whenever you receive an event, this is the first React code that runs this dispatch event function. And so when you blur an element, then the first code the browser is going to run within React is this function. And then this function is the entry point to actually dispatching an event to all of the components that are listening to it. And so we have a little complexity around batching, which I'm just going to skip over. But basically, this is just going to call into this function called handle top level impl or implementation, which is defined at the top of the file. And again, this function also has some complexity that I'm going to skip over. But basically, we look up which DOM node received the event. This get event target either just accesses event.target or event.source element in older browsers, which don't have target. And then we look up the internal React instance corresponding to that DOM node, which is not an object that you ever get exposed as a user, but this is, if you've ever looked at React DOM component, then that is one of those objects which stores a reference to the DOM node and then also some other internal bookkeeping that React needs, like the last props that we rendered for that element, and in some cases for controlled components, we also store a little extra state that we'll need later. But I'm going to skip over this code that I just deleted because it's not important for now. But basically, now we will call another function called handle top level. These are a little bit convoluted names. I don't think anybody's ever tried to go through and simplify all of it. Although hopefully somebody watching this this podcast will feel inspired to make things a little simpler. And so this handle top level is actually this injectable function. So this can be different depending on the configuration. I think it's actually always going to be equal to, is it in this function file? No, it's not. I think it's always going to be equal to this React event emitter mixin handle top level. I'm not sure why it's not just hard coded there. There might be a circular dependency that caused us to do that. And then this just calls into event plugin hub extract events. And so this is, these names for these modules aren't very important. I don't remember most of them, and so but Event Plugin Hub has some more of these methods that we'll need. And so what we do is we call this extract events function, and then we do this run event queue in batch function. And so basically, what this does is first we decide all of the events that we're going to dispatch to the components, and then as part of that, we also decide which components are going to receive those events. After we've decided which events...
I have a question.
Yes.
What is the type of events? Is it an array of what?
Yeah, so events is either going to be it's going to be an array of synthetic event objects, which is which is actually the event object that your event listener is going to be called with from React. So if you write handle blur takes a function that takes an event, then this event is going to be a synthetic event.
So does it mean that one top-level event can create multiple event objects, or
yes,
why is it an array?
So that is possible. In most cases, it is a single event, but in some cases, like especially for the change event plugin, you might have a case where a key up event might end up dispatching a key up event as well as a change event, because we'll notice that the value of an input has changed.
Okay, yeah, that makes a lot more sense. Thanks.
Yeah, so this could be like key up event and change event, and we actually also have an optimization where if this is a single event, then we will just pass that event. So I said this is an array. It's actually an array of synthetic events, or just synthetic event, or it can be null if there are no events. So example, key up event, change event. And we also decide which components are going to receive the events before we actually start calling the event listeners. And so that means that that anything that happens during the event listeners is not going to actually affect which components we're planning to send those events to, which can matter in some cases, like if you're manipulating some of the hierarchies and re-rendering from within your event handlers. When we do extract events, this will already have contain I think it's called .dispatch. I don't remember. Something like dispatch instances. We'll probably run into this in a bit. So event.dispatch instances will be a list of components that we want to send the event to.
Right, so that, like, just to make sure I understand, you have like an input that's inside of a couple of divs. That input and all of its parents would be like on a quick event or a blur event. Is that what you're?
Yeah, that's exactly right. So this would be basically the target of the event and the ancestors.
Cool.
If I remember correctly. And so this extract events, I'm not actually going to open the implementation of this file, but I'll tell you that this just calls into to each event plugin and calls an extract event function of the same name in each event plugin. So this calls. So when I do this, it'll call simple event plugin dot extract events and our enter leave event plugin dot extract events and change event plugin dot extract events. And so we can start with simple event plugin because it is one of the simplest and also is the most common because almost all events go through here. And so what we'll do is in extract events, we'll get the top level type. And so this is something like top blur, as we said. this target inst is going to be an internal React component instance for the event target. So this would be like our React DOM component instance for the input that was blurred. Native event is probably just what it sounds like. That is the actual browser event that we received. Just that event object.
And again, that would be the event that was received on the document, right? But it would be the same event that like was received from the input.
Yeah, so this would be a native browser event, which would have, target is some input, and has type would be blur, and because we captured it at the document, it would also have a current target is the document. And then native event target is just going to be the actual DOM node that was the target of the event. And so this would just be the input DOM node. And so first we check to make sure that simple event plugin is actually has a corresponding event for this top blur. So in the case of top blur, it does want to translate that to an on blur event. But like if we got the top change event, then simple event plugin would not want to do anything. So first we check that here. If it's not one of the events that simple event plugin handles, we just return null. Otherwise, simple event plugin is going to basically convert the native event to one of our synthetic events by wrapping it. And so you can see here we switch based on the top level type, and we're actually going to decide what kind of synthetic event we want to create. And so here's a list of many types, and these are these events all just give us the base synthetic event class, and we don't have any additional properties on it. You might be wondering what additional properties there are. We can look at some of the others to see what those are. And so, for example, top key press, top key down, and top key up end up with the synthetic keyboard event object, which will also have some properties like key code and char code and that sort of thing. You can also see that we actually have a small bit of logic here that says if we get a key press for a function key, then we actually just return null, because I guess Firefox gives us an event for that, but most browsers don't, and we just want to skip over it. And so we'll just return null straight away if we are in one of those cases. But most of the time, for most keyboard events, we will end up creating a synthetic keyboard event. Similarly, for blur and focus, we make a synthetic focus event. For these mouse events, you'll get a synthetic mouse event, and we have drag events, touch events, and a bunch of different kinds of events. And so we figure out which event type we want to make, and then what we do is we then create the event. And so this get pooled method is basically the same as just doing a new event constructor here, but we actually reuse event objects for performance, so we don't cause as much pressure on the garbage collector. And so you can think of this as almost just instantiating this event constructor. So this is something like new synthetic blur event. Right. Focus and blur are both types of focus events. So it would be a synthetic focus event, or a synthetic click event, or a synthetic keyboard event. And so we'll call the synthetic event constructor. And I'll just show you an example of one of these synthetic event types. And so this, I'll go for the mouse event, synthetic mouse event here. And we have a configuration for each event type of how exactly we want to map the native event type to the synthetic event. And so we'll have the property names. And so each property name will either have null, which actually means that we'll just copy it over directly. And so, this is basically equivalent to saying we want synthetic mouse event dot screen x is just going to be equal to exactly the native event dot screen x. And so we're just going to copy this over directly. Same with all of these. But then for some, we actually pass a function which determines the value of that property. And so in this case, the button property on a synthetic mouse event is going to be determined by running this function, which we do when we create the event. And so we'll check whether, so I guess if the event has a which property, then we will return event.button, and that means that it is standard. But I guess in IE8 and older, which is undefined, and so we need to, and button has a value of 1, 4, or 2, but we want it to be 0, 1, or 2, and so we just do that conversion here.
Oh, thank you so much
to normalize
for doing
things.
that.
Yeah. And so you can see we also have some other logic around like page X and page Y are newer properties that are also supported in new browsers, which give you the mouse position relative to the top left corner of the document. But in browsers that don't support page X, so that this event here is really the native event. If that's a little unclear, we check if the native event has a page X, then we'll just use that. Otherwise, we actually have this class called Viewport Metrics, which tracks the current scroll position, and then we'll just sort of polyfill the page X based on what the current mouse position is relative to the screen, and then add in the scroll position so that's the correct thing. And so for each of our event types, we'll have a different configuration like this. Some are more complicated than others. And then this, at the end here, this superclass is not actually that interesting. This basically just calls super when you instantiate a mouse event. And so at this point, we'll we'll create a mouse event or a blur event based on based on converting the properties from the native event to what the synthetic event needs, and then this will just return this instance of the synthetic focus event or synthetic mouse event or whatever it is so far. Does that make sense?
Yeah. What does accumulate to phase dispatches do?
Yeah. So that's the next step. And so at this point we've set up most of the event properties, but we haven't decided which instances we're going to send that event to. And so that's what accumulate to phase dispatches does, which is a very confusing name, but this is what actually handles the capturing and bubbling phases and decides which events or which instances will receive the event. And so the to phase refers to the capturing and bubbling. And so almost all of our events have the to phase dispatches. Some others, which I'll cover if we have time, like the enter leave event plugin, have slightly different bubbling semantics, and so we'll use a different name. But if we actually look at what this function does in event propagators, then this code might actually be a little dense, but accumulate to phase dispatches calls this for each accumulated. Oh, got it. So like I told you before, the result of extract events might be more than one event. As far as accumulate to phase dispatches is concerned, this is either a single event or an array of event objects. And so this for each accumulated is just a loop over them. And so if this is an array, then it just calls for each. If it's a single object, then it just calls this callback with the single event. And so what we do is for each event, and in this case, there's only one for the simple event plugin. For each event, we'll call this accumulate two-phase dispatches single. And what that does is it calls the traverse two-phase helper. This is, let's see, what is, yeah. So, as you're probably noticing, we have lots of nested functions that all seem to do very similar things, and it's not always clear why they're split up into different functions. But what this traverse two-phase does, we can open it. Event plugin utils tree traversal, of course. So there's another.
I'm sure there's a good reason for these layers of abstraction, and if there isn't, then I'm sure that the people watching could submit a pull request, and it would be greatly appreciated.
Yeah, yeah. So the main the event system, the only thing you need to be wary of if you're refactoring it is that the React Native uses the same event system, and that's why there is some of this abstraction, because we don't know if we're actually dealing with DOM components or native components, and we need to have it work in both cases. But apart from that, there is definitely some unnecessary abstraction here.
Actually, a little while ago, this is like good for beginners pull request for you. A little while ago, there was the argument called handler, and you said, oh, that should probably be called like document or element or something. In that function, it was really short, and it basically aliased handler to element. So
yes.
Somebody wanted to submit a really easy pull request, just rename that and get rid of the alias.
Yeah, absolutely. So this will. So we're looking at how we do the bubbling and capturing, and so traverse two-phase is a helper that calls accumulate directional dispatches for all of the ancestors first going down and then back up. And so we can look at the implementation of traverse two-phase. This actually depends on the exact the renderer we're using. So this is different for React DOM and React Native. But here I've opened React DOM tree traversal, which is what we use in React DOM. And so what we do is we just take this instance and we loop over its parent nodes, because on each instance we store a pointer to the parent instance. And once again, all of these instances here are internal React DOM component instances, and so you'll never actually see a reference to these instances if you're using React, because if you take a ref to a DOM node, then you just get that DOM node back. And so we never expose these to you, but these are what we use for our bookkeeping internally to React. And so we have this host parent pointer on each instance, and so we'll just push all the ancestors into an array, and then you can see we call this callback function with each ancestor first in reverse order, and then in normal order. So back to front and then front to back. So we have the instance itself at the beginning of the array, and then its ancestors towards the end of the array. And so we go from the ancestors to the beginning, and then back to the ancestors in the second line. And so this function, you'll recall, is this accumulate directional.
Can you go back for a second?
Yes.
So I just wanted to ask, inst here, is it always a DOM instance? Can it ever be a composite instance?
So inst here is always a DOM instance.
Okay.
And so this instance actually was passed through a number of different places, but it came from here, this target inst, when we constructed the synthetic event. And this was one of the arguments to extract events. And if you go back, it actually came originally from here, where we call get closest instance from node on the native event target. And so this native event target is the actual DOM node, or in some cases, it'll be a descendant of the deepest React node. Like if you were to use dangerously set inner HTML and then get an event on one of the children of that, then we can't do anything with those nodes because React didn't render them. And so get closest instance from node looks up and finds the corresponding instance, if there is one, or the nearest ancestor. That is always going to be a DOM node.
And there would be something similar to that in React Native, right? Like you don't have inner HTML, like the inner HTML concept in React Native.
Yeah. So on React Native, the events come in from the native side over the bridge, and this native event target is actually just going to be a number representing which instance it is, and we just look up which React instance created that. And so when you create a view in React Native behind the scenes, over the bridge we send, I'm going to create a view and I want to call it view 17. And then when the native side has a touch event or something that it wants to send over to JavaScript, then it says, hey, you've received a touchdown event or a touch start event on view 17. And then back on the JavaScript side, we translate that back into the actual instance that was tapped. And so we can look up its properties then.
Cool, that makes sense. Thanks.
And so, so this instance is always a DOM node. We actually completely ignore the composite components in the event system because there's actually no way to events other than by attaching them to a DOM node. That's the only way to add an event listener, is you say, div onClick equals whatever. And so that event listener is always attached to the div. So even though your code that probably handles that click event, you probably defined in your composite component, the event system itself doesn't actually deal with composite components at all.
Yeah, this was not obvious. I just realized that even though the code lives in my components, it's attached to the divs themselves.
Yeah. So that's a good observation. And so let's see. So we are looking at traverse two phase, and so this calls a callback for every for the instance itself and all of its ancestors, and it goes in both directions. And so for each of these ancestors, we end up calling this accumulate directional dispatches function. And you can see actually this traverse two phase passes as the second argument, whether it passes false when it's going down the tree and then true when it's going back up. So we can differentiate capturing from bubbling. And so this upwards will be false for capturing and true for bubbling, which you can see right in this next line will pass phase is either bubbled or captured. As for why we don't just pass bubbled or captured here instead of true and false, I don't know.
Probably a good pull request right there too.
Yeah, that would also be a good simplification. So what we do is, so we actually look up at this stage is when we look up to see if there are actually any listeners for this event. So we're processing this instance, and we say we have this click event on this input, and maybe its ancestors are these divs. And for each of those nodes, we actually want to see if we have any React event listeners for that node. And so we can see what listener at phase does. This is not super interesting, so I'm not going to go into the details here, but basically each instance has root node ID, I believe we call it, which might be equal to 17 again. And that's different for every React DOM node in the document, even if you have separate React trees. And then we basically store a big map.
I have a question about root node ID. So the naming confused me because it's not ID of the root, right? So each instance actually has a different ID. It's like its ID.
Yeah, it is a confusing name. So it's actually the reason it's called root node, I believe, was to differentiate it from composites, because it used to be that composite nodes would also have this root node ID, but it would always be the ID of the DOM component it rendered. So so if you have a number of layers of composite components, they would all have the same root node ID. So probably DOM node ID or host node ID would have actually been a better name, but it is called root node ID.
So let me make sure that I understand that, because it's not entirely clear to me. So you're saying the difference between like DOM nodes like a div versus React components that I make, like an avatar widget or something like that?
Mm-hmm.
Okay, and so if the root node ID on an avatar widget would actually be referencing the closest parent that's an actual DOM node? Is that what that means?
So it's actually not the parent, but it would be the DOM node that it rendered. So if your avatar widget renders a div, then if you had a handle on the internal React instance for your avatar widget, which again we don't ever expose, then its root node ID would be the same as that DOM node's root node ID.
Cool. So
I'm actually not 100% sure that we still have root node ID on composites. I think I might have gotten rid of it. But if it is there, then it's always the same as the DOM node that it renders.
Okay, and that would be the same case if I had avatar and that immediately the root of that was like photo, and then ultimately got down to image, then all of those components all the way down. Okay.
All of those would have the same ID.
Makes sense.
And so we just store these listeners in a big map. So this has something like this, 17, and then we'll just have on blur is going to be at some function handle blur probably that you defined in your component. And so when we mount a component on the screen, we store its event listeners in this big map. And then at this stage, this listener at phase is just going to go and look up to see whether there is a listener for this instance, for this particular DOM node, for this event.
Is there any particular reason why we use a map with IDs over just putting the stuff on the instance itself?
No. So this actually dates back to, it used to be that instead of these instances, we passed around IDs. You might remember, in data React ID, we had these long hierarchical IDs that were basically, the keys for your components, but split up with dots in between them. And the entire event system actually ran on top of these hierarchical string IDs. And so what we did was the event system would actually literally take that string, split it up on the dot character, and do bubbling that way. And so if you had a.b.c, then it would say, oh, the instance a.b.c received the event, but so I'm going to also send the event to its parents, a.b and a. And we actually never got a handle onto the internal React instance for a node when processing an event, which is kind of weird to think about. But back then, this map was, a.b.c or something like that. Nowadays, I did end up refactoring this quite a bit, and we do have a full reference to the instance now. And so it would be a lot easier to just store it on the instance directly. And we probably should do that, although it hasn't been a high priority for us to do that refactor, just because the current system does work. In fact, we actually don't need to store it separately, because on each instance, we already have a copy of the props. And the props have all of these event listeners on them. And so, the props for a component do have, on blur and some function, and they might also have other props like value or class name, but that's okay. And so this is inst.current element.props, something like this. And so we could just actually look in that props object directly to see was there one of these event listeners in the props. But we haven't done that refactor. And so we get this listener function, or null if there is no listener. But if there is a listener, then we'll store it on this event.dispatch listeners. And so dispatch listeners is basically an array of the functions that we're going to call for an event. This accumulate into, again, is just a helper we have to deal with either a single listener or an array of listeners. And so this is basically, this line is basically, you can just think of it as .push listener.
I a small question. Does it still make sense, like with modern agents, does it still make sense to try to like optimize on array allocations here?
That's a good question, and something that we haven't revisited too much, but it might be worth looking at because it does add a little complexity to the code. Yeah, so we end up looking up all of the listeners that we might have, and then storing them on the event. And we also store the instance. This is, so for each listener, we also store the corresponding internal instance. And I believe we only use that to set current target. So the way current target works is it's always the points to the DOM node that so that always points to the DOM node whose event handler is currently running. So if you have an input and it's contained by a div, then .target will always be that input if that input received an event. But if you add an event listener to the input, then the current target will be the input. But if you add the event listener to the parent div, then that current target would be would point to that parent div. And so I think that's the only thing we use this dispatch instances for. And I think we'll hit that code in a sec, and I can show you. So basically, that's what this accumulate two-phase dispatches does. And so at this point, event.dispatch listeners is now populated. And that's just the array of event handlers that we're going to call. And so we return this from extract event, from extract events, and then we call queue events. I wonder what that does. As you can see, I also don't remember this.
It's a big code
queue
base.
Events.
A lot of people work on this.
Actually, I'm not sure what this event queue is for. I'm actually curious now, so maybe you can search for it. Some of the other, well, whatever. It's not important. But we say basically we're going to now process these events and dispatch them to the individual components. And so there's some extra logic here around error handling, but basically we just loop through the events, and for each event, we're going to call this function execute dispatches and release top level, which calls for each event, calls this execute dispatches in order, which just loops over these event listeners and essentially calls them. And then it's going to release the event back into the pool. Because remember, I said we keep a list of the events that we've created, and we reuse them. Here is where we put them back into the pool. And so the only thing left is actually seeing how we actually call these event listeners, which is in event plugin utils. Again, not sure why these are really different files, but we loop over the event listeners. And so we take the event and get the listeners and instances. This dev only check, I think, just makes sure that those are the same length, because they should always be created at the same. And then we just loop over them. And so the first thing we do is we check has somebody called stop propagation, because we queue up and say, oh, we're going to run these 5 event listeners. But if somebody calls stop propagation before we've executed those 5 listeners, then we should actually stop in the middle. And so that's what this check is for. And then we call execute dispatch with the event object and the event handler. And this, again, has some extra logic for error handling. And so I'm just going to comment this out. But this is basically, we're just going to call listener of event at this point. And so,
oh, come on, let's go into the code. I want to see where it actually calls my listener.
Okay, so in React error utils, we have invoke guarded callback. And so, wow, my syntax highlighting does not like this. It's gonna, looks reasonable. So in development mode, this is going to seem very roundabout, but we actually, when calling a listener, we actually create a fake event object in the browser and use the browser's event system to dispatch that event to that event listener. So what we do is we actually create a fake node, add a native event listener to it, and then end up adding the event listener that we're about to call, and then dispatching a fake browser event to that node so that the listener gets called. And the reason we do this is it actually has slightly better error behavior. Basically, this is treated as a try-catch. So if the handler does throw an error, then the browser is going to take care of not bubbling this up. And so the rest of the event code will continue to run. Now, of course, we could also add our own try-catch, but that tends to make debugging harder, because then if you set in your dev tools that you want to break whenever there's an exception, then you're not actually going to get stopped until we rethrow that error. And so this is a very tricky way that we've devised of having the browser call into the event handler function, and then that works a little bit better in the browser dev tools.
So actually, I'm a little bit curious. If I were like interoping with Backbone or something, and Backbone was rendering my stuff, would this development mode kind of mess things up in terms of propagation and stuff, or is that not really something to be concerned about?
So React does all of the event propagation itself, and so actually it's still going to, so regardless of any other event listeners that you have, once React gets the event, it's going to do the same thing. And React's event system does not actually integrate with browser events so if you have like a native click listener and a React click listener, and you call stop propagation in one of them, it's actually not going to affect the other. And this is occasionally a little inconvenient, and we've had some issues open on the React repo about this, but that's something that we don't really support.
Yeah, it seems like a pretty edge case issue.
Yeah, but this method of calling the callback actually is separate from that issue, and this works regardless of what other libraries you're using, so in non-dev mode, so this is what we do in dev mode. It's a little complex and probably a little slow. In non-dev mode, we actually do just call it with a try catch, and so this invoke guarded callback, which recall we're doing right here, is we passed it the event type, the listener, and the actual event object. Here we get the type, which we actually ignore. That was only used for debugging down below. But we get the event listener and the event object. And here is where we actually call that function. And so this is right. This calls into your event handler function that you added to the DOM node and passes it that function.
Yay!
And then we also have some logic where we actually, if that throws an error, then we actually catch it now, and then we'll end up rethrowing it after processing all the events to make sure that you do still see that you had an error, and that is not important. I don't know where that is, but somewhere we do near the end of the event handling process, we do call this rethrow caught error function, which will throw an error if there was one thrown previously. And I sort of skimmed over. So that this invoke guarded callback we said calls the event. I sort of skipped over how current target is set right here. As a reminder, we had the dispatch listeners and the dispatch instances. I said those are only used for current target, and I believe that's still correct. So this instance is once again one of our internal DOM node instances or DOM node wrappers. And so what we do is we look up what the actual native DOM node is, which you would get from the browser, and then set that to the current target right before calling the event listener. And then right afterwards, we actually set it back to null.
And that way it's not like document, like you were talking about a little bit before, and it's what you would expect it to be, even though the element that's actually listening to that event was document. That's
right. So that's pretty much it. We have some other event plugins besides simple event plugin, but I don't think we really have time to dig into those. But they do have similar logic of taking a top level of event, like the enter leave event plugin takes either mouse over or mouse out events, and then figures out exactly which components should receive the enter and leave events, and then those won't call this accumulate two-phase dispatches. It'll call another helper, but in the same way, dispatch listeners will get populated with all of the event handlers that have been attached, and then we'll end up calling those listeners, no matter which event plugin created the event. So I think that's about all I have. Do you guys have any questions?
Yeah, I was wondering, do you ever see React Web using this system to implement some kind of gestures?
Yeah, so one of our event plugins is actually this responder event plugin, it's called, and this implements sort of a sophisticated system where you have some concept of a current responder, and what that is that's basically the current node that's receiving touch events and that sort of thing. And so what that does is then it regardless, when it gets more touch events, it always sends them to that current responder first before setting them to any other nodes. And it can do that by taking the top level touch start event and it says, oh, is there a current responder? If there is, then I'm just going to send this event directly to the responder node and give it a chance to handle that first before doing anything else. And so we definitely have the flexibility here to make very, very sophisticated event plugins such that the output of the events is going to be different from the incoming browser events. I'm not sure at this stage whether the system would be a perfect fit for gestures, but it does give us a pretty good amount of flexibility, and so I think that there's a good chance that we could reuse most of it if we did want to support gestures inside of React.
Cool. Yeah, that's it for me. So Dan, did you have any other questions? Cool. Ben, did you have anything else that you wanted to bring up?
No, I don't think so. I hope that was helpful. It was a little more code than I remembered, so hopefully it didn't drag on too much.
No, it was great. I'll submit a pull request to add a link to this video in the contributing docs, and hopefully this is helpful for people in the future. It was enlightening to me,
Sure.
so thanks.
Absolutely. Well, thanks for having us.
Yep. See ya.
See ya.